Hello students, how are you all? I hope everyone is doing well. So in the last class we are doing the chapter on triangles, right? And we have already learned the congruence criteria, then we have learned about the side criteria and the side angle criteria, right? So today we will be moving on with some more properties of triangles. Okay, so let's start with today's class. Okay, so see here. Now I hope you all know about isosceles triangle, right? So what is an isosceles triangle? If the two sides of a triangle are equal, that means if these two sides are equal, then we call this triangle as an isosceles triangle. Say for example, this is 2 cm, this is 2 cm, and this is say 3 cm. So that means these two sides have equal length. So we call it as an isosceles triangle, right? Isosceles triangle. Okay, now see here, it is written also, a triangle in which two sides are equal is called an isosceles triangle. Now if we measure these two angles, then what we will get? So this is the first theorem. Okay, now see here, the theorem 7.2 says that angles opposite to equal sides of an isosceles triangle are always equal. That means since these two sides are equal, so angles opposite to the equal sides, these are the angles which are opposite to the equal sides of an isosceles triangle is also equal. That means if this angle is 45 degree, this angle should be also equals to 45 degree. Okay, this should be the criteria. Now here the proof is given. We are given with an isosceles triangle ABC. This is an isosceles triangle in which AB is equals to AC. So what we need to prove that? We need to prove that this angle B and angle C are equal. Okay. Now what we have drawn? We have drawn a bisector of angle A and D be the point of intersection on the side BC. Okay. Now in triangle BAD and CAD, what we have got? We have got that AB is equals to AC. It is already given, and angle BAD is equals to angle CAD. Why? Because we have drawn that bisector of angle angle A. Okay, by construction, and also we have AD is the common side, right? For both the two triangles, for both these triangles, AD is the common side. So therefore we can say that by side criteria, what we can say that these two triangles are congruent, right? And we know that corresponding angles of a congruent triangle are also equal. That means by CPCT, corresponding parts of congruent triangles, that means what we can say that angle ABD is equals to angle ACD. That means these two angles are equal by CPCT. Understood? Easy one. Okay, now is the converse also true? We need to show this, and we can, yes, obviously the converse should be also be true, right? Because what we will get? We will get that these two sides AC and AB will be definitely equal in an isosceles triangle, right? So definitely the converse is also equal. We can prove it with the help of an example, right? Next theorem. See, since the theorems are given here directly, so I don't think that I have to write it once again. Already it is given here, and you can use this as example also. Okay, now the opposite sides to equal angles of a triangle are always equal. That means the opposite sides of to the equal angles, if these two angles are equal, then obviously these two sides are also equal. This is what the theorem 7.3 speaks. Okay, now moving on to the examples, and we then and after that we can move on to the exercise. Okay, here some examples are given. Now using the properties, that means of the isosceles triangle, we can find this, solve these examples. Now if we move on to the, let's move on to this exercise 7.2, your doubts will be clear then. Okay, now see here, it is given that first question, in an isosceles triangle ABC, ABC is an isosceles triangle with AB equals to AC. Okay, with AB equals to AC, the bisectors of angle B and angle C intersect each other at point O. we have to draw this as a construction. Okay, now see here how we can draw the diagram. Say this is the triangle. Okay, this is an isosceles triangle. Okay, where AB is equals to AC. Say this is the triangle ABC and this is the side AB equals to AC. Now bisectors of angle B and angle C, bisectors of angle B and bisectors of angle C meet each other at point O. Okay, join AO, and also we need to join AO. Okay, we have joined AO. Now what we need to prove? We first of all we need to prove that OB is equals to OC. That means these two sides are equal. First of all we need to prove that, and also secondly OA is the bisector of angle A. We need to prove this. Okay, now let's do it. First of all, write given. What is given? Given ABC is an isosceles triangle, right? Where AB is equals to AC, right? The bisectors of angle B and angle C meet each other at point, what point? O, right? And also OA is joined and AO is joined, right? So what we need to prove? To prove, first of all, number one, these two sides are equal, that is OB is equals to OC. And secondly, what we need to prove? OA is the bisector of angle A. AO is the AO bisects angle A. Bisects angle A. Now the proof. Now see here, for the first part, since ABC is an isosceles triangle, since ABC is an isosceles triangle, obviously angle B is equals to angle C, because we already know that if two sides of a triangle are equal, then their opposite angles are also equal, right? We already know this. So therefore what we can say, that angle B is equals to angle C, right? Now see here, since you can write here that from theorem 7.2, that means if two angles are equal, then the opposite sides are also equal. Therefore if the opposite sides are equal, then the opposite angles are also equal, right? Next, since OB and OC is the bisector of angle B and angle C, therefore what we can write? Since OB is the bisector, so it will be half of angle B is equals to half of angle C, right? Understood? Because OA and OB bisects angle B and angle C, therefore it will be half of angle B, right? Since OB bisects angle B and OC bisects angle C, right? Now what is half of angle B? Half of angle B is nothing but this part, right? So that is angle OBC, which implies angle OBC is equals to, what is half of angle C? That means OCB, right? Angle OCB. You can write here angle bisector. So what we have got, therefore from here, if these two angles are equal, then what we can say, that if the opposite angles of a triangle are equal, then their two sides are also equal. That means these two sides are also equal. Therefore OB is equals to OC, right? You can write here sides opposite to equal angles are equal. Okay, now see here, in triangle AOB and triangle AOC, these are the two triangles. Okay, in these two triangles, from here what we can say that, question now number 2, in triangle AOB and triangle AOC, from these two triangles what we can say that, see here, since AB is equals to AC, it is already given, AB is equals to AC, it is already given. Next AO is the common side for both the triangles, right? That means AO is equals to AO, which is the common side. And also we have OB is equals to OC, right? We have already proved this one, so we can write OB is equals to OC. Okay, so this is side, and this is also side. That means side criteria. Therefore, by side criteria, what we can say that these two triangles are congruent, right? Triangle AOB is congruent to triangle AOC, right? Now see, since these two triangles are congruent, therefore by CPCT corresponding angles are also equal. So we can write that by CPCT, by corresponding parts of congruent triangles, what we can conclude that angle, see here, BAO, right? This angle is equals to CAO, right? That means these two angles are equal. So if these two angles are equal, then definitely AO is the bisector of angle A. So what we can say that angle BAO is equals to angle CAO, right? So from here what we can say that, hence AO bisects angle A, which is our required proof, right? Since these two angles are equal, BAO and CAO, these two angles are equal, so definitely this is the bisector of angle A, right? Understood? Okay, moving on to the next question. Okay, now see here, in triangle ABC, a triangle is given. Okay, AD is perpendicular to BC. We have AD is the perpendicular bisector of side BC. What we need to show that ABC is an isosceles triangle in which AB is equals to AC. Okay, these two sides are equal. We need to show this, and we have to first of all show that this ABC is an isosceles triangle. Okay, so now the proof. Given, first of all, since the diagram is given here, I will not draw it again. Okay, given AD in triangle ABC, AD is the perpendicular bisector of side BC, right? Now what we need to prove? To prove AB is equals to AC. Okay, we need to prove this. Now the proof. Now see here, since AD is the perpendicular bisector of the side BC, so therefore it will make two triangles, right? One triangle is ABD, or else you can say that ADB, and the other triangle is ADC, right? So we have in triangle ADB and triangle ADC, we have two triangles here. So in these two triangles, what is common here? See, in these two triangles, this side, this line is common, this side is common to both the triangles. So that means AD is equals to AD, which is the common side, right? Next, angle ADB, this angle is 90 degree, right? Is equals to this angle is also 90 degree. So that means we can say that angle ADB is equals to angle ADC, which is equals to 90 degree it's okay. And BD is equals to this side is equals to this side DC. Why? Because AD is the perpendicular bisector and it cuts the side BC at point D, which is the midpoint of this line. Okay, so you can write that BD is equals to CD, since AD is the perpendicular bisector. Okay, since AD is the perpendicular bisector. So what we can conclude? We can conclude that therefore by, see, this is side, this is angle, and again this is side. So what is the criteria? By side angle side criteria. By side angle side criteria, what we can say that these two triangles, that is ADB and triangle ADC, are equal, right? So we can say that therefore triangle ADC is congruent to triangle ADB and ADC. ADB is congruent to triangle ADC. Okay. Now see here, since these two triangles are congruent, so therefore what we can say that by corresponding parts of congruent triangles, what we can say that AB is equals to AC, right? That means these two sides are also equal. Okay, these are the corresponding sides. Understood? Okay, this is the required proof, hence proved. Okay. Now moving on to the next question. See here, the next question here is given as, in triangle ABC is an isosceles triangle. Okay, ABC is an isosceles triangle in which altitudes BA and CF are drawn to equal sides. Okay, sides AC and AB respectively. We have to show that these altitudes are also equal. That means in this triangle, ABC is an isosceles triangle. Okay, here BE and CF are drawn to equal sides AC and AB. That means these two sides are already equal. It is given AB and AC are two equal sides. Okay, this is given, and these are the altitudes. Okay, we have to show that the altitudes are also equal. That means BE is equals to CF. We need to show this. Okay, now let's do it. Okay, since the diagram is given, so I will not draw the diagram. Okay, I will not draw the diagram. Now since given here, what is given here? ABC is an isosceles triangle, right? ABC is an isosceles triangle, right? In an isosceles triangle, these two sides are equal. That means AB is equals to AC. Okay, now see, the altitudes are also equal. So it is given that BE and we need to prove that these altitudes are equal, but it is given that BE and CF are the altitudes. BE and CF are the altitudes, right? It is given altitudes. So what we need to prove? To prove BE is equals to CF. Okay, now see here the proof. See, first of all, in this triangle AEB and in the triangle AFC, these are the two triangles. That means in triangle AEB and triangle AFC. Now first of all, this angle A is the common angle to both these triangles, right? Since this is a common angle, so what I can write? Angle A is equals to angle A. Why? Because it is the common arm, right? Next, angle AEB is equals to angle AFC. Why? Because this angle is equals to 90 degree and this angle is also equals to 90 degree. Since they are 90 degree each, so therefore we can write that angle AEB is equals to angle AFC, which is equals to 90 degree each. They are right angles, right? Next, AB and AC, since this triangle is an isosceles triangle, so definitely the two sides are also equal. So we can write that AB is equals to AC. It is already given also. AB is equals to AC, which is given. So see here, this is angle, this is angle, and again this is side. So what is the criteria? The criteria is angle, side, and angle, or else you can say that angle, angle, side criteria, right? So therefore by angle, angle, side criteria, what we can say that? We can say that triangle AEB and triangle AFC are congruent. Triangle AEB is congruent to triangle AFC, right? So that means these two triangles are congruent. Now, since these two triangles are congruent, so therefore by using CPCT, that means corresponding parts of congruent triangles, what we can, so that the altitudes, that means the sides BE and CF are also equal, right? So therefore by corresponding parts of congruent triangles, CPCT, we can say that triangle, we can say that BE is equals to CF, right? Because they are the corresponding sides. Okay? Okay. So this is the required proof. Okay. So moving on to the next question. So the next question here is given as okay. So the next question here is given as ABC is a triangle in which BE and CF two sides AB and AC and AB are equal. This is the figure. Okay, the figure is given here. What we need to show that? We need to show that triangle ABE and triangle ACF are congruent, and also we have to show that AB is equals to AC, right? Already since question number 3 we have done, so question number 4 is similar, and you just try it as your homework. Okay, just try it as your homework. This is similar to question number 3. You can do it by using the criteria what we have already studied. Okay, moving on to the next question. See here, triangle ABC and DBC, ABC and DBC are two triangles. Are two what triangles? They are isosceles triangle. That means their two sides are equal with the same base BC. The base is same for both the triangles. What we need to show that this triangle angle ABD is equals to angle ACD. That means these two angles are equal. We need to show this. Okay, so let's do it. Now, see here, since the diagram is already given, I will not draw the diagram. Triangle ABC and okay, here you need to draw one construction, that is you have to join these two sides, these two angles, that is angle A and angle D. You need to join it. Okay, so this is only the construction which you need to draw. So I have already drawn here. Okay, now see here, given first of all ABC and DBC are two isosceles triangle. It is given isosceles triangle. Okay, what we need to prove? We need to prove with same base. You can also write with same base BC. what we need to prove? We need to prove that angle ABD is equals to angle ACD. Now the proof. Since these are the two triangles, so therefore in triangle ABD and triangle ACD, these are the two triangles, right? So in triangle ABD and triangle ACD, since these are the two triangles, AD is the common side, right? If I take this triangle and this triangle, so which is the common side? AD is the common side, right? So I can write AD is equals to AD. Why? Because it is the common arm, right? It is the common arm. Next, we have AB is equals to AC. Since this is an isosceles triangle, so definitely the two sides will be equal, and it is already given, that is AB is equals to AC. Since ABC is an isosceles triangle, ABC is an isosceles triangle, right? Next, again see here, BD is equals to CD. Why? Because BDC is also an isosceles triangle. We can write here BD is equals to DC. Why? Because DBC is also an isosceles triangle, right? So what criteria we have? This is side, and again this is side. So that means by side criteria, what we have? We have that this triangle ABD is congruent to triangle ACD, right? Now, since these two triangles are congruent, so what we can say that by CPCT, by corresponding parts of congruent triangles, we can say that angle ABD is equals to angle ACD. That means the corresponding angles are also equal, right? So by CPCT, angle ABD is equals to angle ACD. Hence, this is the required proof. Okay. Just remember that this chapter is very easy. You just need to understand the things what I have taught you. Okay. Otherwise, this chapter is very easy. Only by using these 3-4 theorems, you can prove the whole chapter. Okay. Now, moving on to the next question, that is question number 6. Okay. Here it is given that ABC is an isosceles triangle. Okay. In which AB is equals to AC. The figure is already given here. ABC is an isosceles triangle in which AB is equals to AC. These two sides are equal. Now, side BA is produced to this side is produced to the point D. That means it is extended such that this side is equals to this side. That means AD is equals to, AB is equals to AD. This side is equals to this side. Okay. Now, what we need to show that? We need to show that angle BCD is equals to 90 degree. That is, it is a right angle. Okay. We need to prove this. Now, the diagram is given here. So, I think I need to draw the diagram. Okay. So, given here triangle ABC is an isosceles triangle, right? Next, in which AB is equals to AC. Okay. Side BA is produced to D such that AD is equals to AB. Okay. So what we need to prove? To prove angle BCD is equals to 90 degree. That is, it is a right angle triangle. Right. We need to prove this. So now the proof. So first of all, what we'll consider? We consider the triangle ABC. Consider triangle ABC. In this triangle ABC, what is given? AB is equals to AC. It is already given. So we can write AB is equals to AC, given. Next, angle ACB is equals to angle ABC. That means if two sides of a triangle are equal, then their opposite angles are also equal. We already know this from theorem 7.5, right? So we can say that angle ABC is equals to angle ACB. Why? Because they are opposite angles opposite to the equal sides. Since they are angles opposite to equal sides. Okay. Now again, in the next triangle, that is triangle ADC, this is the second triangle, right? Now consider triangle ADC. Consider triangle ADC. Now see here, in this triangle ADC, we have AD is equals to AB, right? So we can write AD is equals to AB, since it is already given. Now angle ADC, this angle is equals to angle ACD. Why? Because see here, from the first triangle these two sides are equal. From the second triangle, what we have got, that this side and this side also equal, and if this side is equals to this side, then definitely this side is equals to this side, right? So that means from here we can get that AD is equals to AB, which is equals to AC, right? This is the third side. So that means what we can say? We can say that angle ADC is equals to angle ACD. Angle ADC is equals to angle ACD. Why? Because angles opposite to equal sides. Since they are angles opposite to equal sides, right? So now in triangle ABC, again take this triangle ABC, and we already know that interior angles of a triangle is always equals to 180 degree. So that means angle CAB plus angle ACB plus angle ABC is equals to 180 degree, since interior angles of a triangle is equals to 180 degree. We know this thing, right? So now we already have proved that angle ACB is equals to angle ABC, right? ACB is equals to angle ABC. So also we can write that angle CAB plus angle ACB plus angle ACB is equals to 180 degree. Why? Because since angle ABC, it is already, we have proved that, right? ABC is equals to angle ACB. ABC is equals to angle ACB. Now these two angles are equal, so that means it will be angle CAB plus twice of angle ACB is equals to 180 degree, right? So we can write this equation as, if we take this twice ACB to the right hand side, it will be minus of twice ACB. So that means we simplify angle CAB is equals to 180 degree minus twice of angle ACB. Let this be equation number 1. Now again in the triangle, similarly in triangle ADC, now take the second triangle, that is ADC. We have angle CAD this time, right? and CAD is nothing but CAB. Angle CAB. Okay, before going to this part, you can write one thing here. Let's write like this. See, no, similarly in triangle, ADC, what we can show that in triangle ADC, in the interior angles of a triangle is equals to 180 degree. So that means angle CAD plus angle ACD plus angle ADC, right? And ADC is equals to angle CDA. So therefore we can write that 180 degree minus twice of angle 180 degree minus twice of angle ACD. Okay, this is equation number 2. Now also, since BD is a straight line, therefore what we can say that, therefore angle CAB plus angle CAD plus angle CAD is equals to 180 degree, right? So that means what we can write? We can write that adding equation 1 and 2. That means adding equation 1 and 2, this equation and this equation. What we will get? Angle CAB plus angle CAD is equals to 180 degree minus twice of angle ACB plus 180 degree minus twice of angle ACD, right? So already we have found that angle CAB plus angle CAD is equals to 180 degree. So that means we can write here, which implies 180 degree is equals to, now see here, 180 degree plus 180 degree, it is 360 degree. 360 degree minus twice of angle ACB and CAD. ACB minus twice of angle ACD, right? So 180 degree minus 360 degree. So I can write here 180 degree is equals to 360 degree minus, if I take 2 common, that it will be angle ACB plus angle ACD, right? So if I take this to the left hand side and this 180 to the right hand side, it will be twice of angle ACB plus angle ACD is equals to 360 degree minus 180 degree. 360 degree minus 180 degree. That means twice of angle. Now see here, angle ACB and angle ACD. So that means AC is the bisector of angle C. So that means this angle will be equal. That means this is the angle, required angle DAC, or you can say that BAC, right? So angle BCD is equals to 360 degree minus 180 degree is nothing but 180 degree. So that means angle BCD is equals to 180 degree divided by 2. That means 90 degree. So therefore we have angle BCD is equals to 90 degree, which is the required proof. So here we need to prove that BCD is a right angle triangle. Okay, understood? Okay, till today we are stopping here. In the next class we will be doing from exercise 7 and 8. We will be doing these 2 questions, and after that we will see some more congruence criteria and we will complete the chapter. Okay, thank you.